All right, so our test over polynomials will be next Thursday. So be you ready for that? We'll have several reviews before then. The first section here says prove the following identity. And to do that, you need to just make the one side equal the other side. And it's going to be easier in my mind to multiply this side to make it equal the other side. So remember, whenever you square something, you write it out twice and multiply it with itself. And then you just distribute and combine like terms, and then if it becomes the other side, then it's a true identity. So we have 2x times 2x, so 4x squared. 2x times the y is going to be plus 2xy. Then we're multiplying the y times the 2x, so we'll have another 2xy. When you multiply the different letters, you just stick them beside each other. Then we have y times y, it's going to be y squared. Then we have some like terms in the middle, so we'll have 2 plus 2 gives you 4, xy. Drop the 4x squared down, and look at that, it is the same. Just drop the other side down and show me. Yep, they are the same. Once you've got them equal to each other, then you're done and move on to the next one. So that's all you're doing there is just multiplying what you need to multiply and test it to see if it equals the other side. Okay, these here you're dividing. So you have the two options. You can do long division or synthetic division when the coefficient is 1. And remember, synthetic division, just list out all the coefficients. So we have 1, 13, 26, negative 93. Leave a space, put a box, and in the box you put the opposite of this number here, so negative 9. Then we drop down the first number, 1 in this case, and then multiply in the box and put it in the next spot. So I have 1 times the negative 9 is going to be negative 9, and then I add down. So 13 plus negative 9 is going to give me 4. Multiply with the box. 4 times negative 9 make negative 36. Add down, negative 10. Multiply in the box. It's going to be a positive 90. So this last number is your remainder. And then you just write out your answer. The exponent drops down by 1. So the first one's going to be 1x to the second. And then you just continue dropping your exponents from there. 1x squared plus 4x minus 10. I'm just pulling those straight from there. And then the remainder, it's a negative, so I'm going to put a minus, put the remainder over whatever we divided by. And there you go. These two word problems here create 3 different polynomials that could be divided by x minus 4 without any remainder. So you're just, if you want to create a polynomial that can be divided by it, this has to be a factor. So this is a factor that you have to use, and then you can use whatever you want. So you can have x minus 4 times x plus 5. You can have x minus 4 times 2x minus 2. You can have whatever you want. Just give me 3 of them and make them different than mine. Alright, so there's my 3. And then once you've got them, just multiply them together and get your polynomial. So you just distribute. So x times x, x squared. X times the 5, 5x. Negative 4 times the x, negative 4x. And then negative 20. Just combine the like terms. We got x squared plus x minus 20. So there's my first polynomial, and just continue multiplying all 3 of them until you get all 3. For the intersections of the functions, use Desmos, the graphing calculator, to find the intersections. And you're just looking for the point where they cross, or points if there's more than one. These two, 15 and 16, 15, they're very much the same. It says 2 friends are collecting baseball cards. The first friend is collecting cards at a rate that can be modeled by this polynomial, and the second friend is collecting cards at a rate that can be modeled by this polynomial. write a polynomial that would model the two collections combined. So if you're combining two collections, you're simply going to add them. All right, so we're just going to take f of x plus g of x. So you're just going to add the two functions together and then combine any like terms. That's all you're doing. So combine the like terms and then you got your answer. Same with 16. Describe the end behavior. So put them in the graph, and the end behavior is what we were doing in the previous assignment. You just want to know what's going on the far ends. Are you going up or down as you get to the end? So your answer is going to be as x goes to positive infinity, f of x goes where? So the answer is either going to be positive or negative infinity. Then you'll say as x goes to negative infinity, where does f of x go? All right, so it's either going up or it's going down. So it's going to be positive infinity or negative infinity.